How do convolutional neural networks classify images? Imagine teaching a computer to see and understand pictures just like humans do. That's what convolutional neural networks aim to do. They are a special type of artificial intelligence designed to recognize and categorize images. When an image enters a convolutional neural network, the first step is to prepare it. This usually means resizing the image to a standard size, like 128 by 128 pixels. The image is also normalized, so the pixel values are scaled to a common range, making it easier for the network to learn. Sometimes, images are augmented by rotating or flipping them to help the model recognize objects from different angles. Next, the image passes through what are called convolutional layers. These layers use tiny filters, also called kernels, that slide over the image. Each filter looks for specific patterns like edges, textures, or colors. Early on, the filters detect simple features like straight lines or color changes. As the data moves deeper into the network, the filters find more complex patterns such as shapes or parts of objects. This layered approach is similar to how our eyes and brain work together to understand what we see. After the convolution step, the network applies an activation function, often called ReLU, which turns all negative values into zero. This step introduces nonlinearity, allowing the network to learn more complex patterns. Then come pooling layers. These layers reduce the size of the feature maps by summarizing small regions, often by taking the maximum or average value. Pooling makes the model faster and more tolerant to small shifts or distortions in the image. It helps the network focus on the most important features rather than getting distracted by minor details. Once the features are extracted and condensed, the network flattens the data into a single long vector. This vector is fed into fully connected layers, which act like traditional neural networks. These layers combine all the learned features to make a final decision about what the image shows. The last step is the output layer, which uses an activation function called softmax. Softmax converts the raw scores into probabilities for each category. The category with the highest probability is the network's prediction of what the image contains. This process is used in many applications, from recognizing objects in photos to facial recognition, autonomous driving, and even medical imaging. AI systems like DALL-E and Midjourney use similar principles to generate images based on learned visual concepts. Understanding how convolutional neural networks classify images helps us see how machines interpret the visual world. It's a step toward smarter technology that can assist us in countless ways while raising important questions about ethics, privacy, and bias. Knowing this process makes it clearer how AI can be both powerful and responsible in its use.